Okay, hi everybody. Today we're going to talk about, or at least the next 5 minutes hopefully, talk about how to take a square piece of cardboard and make some cuts in it so that we can fold it up to be a box, and we're trying to figure out how to get the maximum volume here. So we'll put a fold right here, a fold right here, a fold right here, and a fold right here, and we're going to get a box that looks like this. I don't know if it's going to be exactly a cube. We'll be able to figure that out after we figure out how to set up the equation that's going to allow us to maximize this volume. So this would be your x value, and let's say we'll give it a specific dimensions, a square. So let's say it's 10 by 10 inches or something like that. So 10 inches by 10 inches. Okay. So we're going to have to figure out how big these squares need to be so that when we cut them out, we maximize the volume here. So if this is 10 and this is x, right? Wouldn't this be what? Anybody in the audience know?
10 divided by 3.
Not 10 divided by 3. This distance here would be 10 minus 2 x's. Right? Alright. So this right here is 10 minus 2 x's. Now what's the height of the box?
10 inches.
No, it's not 10 inches. This height right here
that height
is going to be what? If this is gone, this will be gone. This will be gone. This will be gone. This will be gone. And then these guys fold up.
10 minus 2 x's.
Not 10 minus 2 x's. This is 10 minus 2 x's, because this is 10 minus the two amounts that are going to come in here and get folded right here.
Okay.
This height that I flip up is going to be x. Does that make sense?
Yes.
This is going to be x right here. And if it's a square, and if this is x and this is x, that means that this height is going to be x, and what else now? What's the third dimension? Okay, here's x, here's 10 minus x. What would this length be? Right? If this is 10 minus x, sorry, 10 minus 2 x's, then wouldn't this be the same? If
Yes.
it's a square? So this is 10 minus 2 x's as well. Okay, so what are the dimensions of the box? The height is x, and the length and width, since it's probably going to be a cube, or at least it's going to have a square bottom, it's going to end up being 10 minus 2x, along with another 10 minus 2x. Hopefully you can follow my handwriting here. Alright, so, dimensions of the box. The volume of the box is the length times the width times the height. Well, the height we said is going to be x. The length and the width are going to be this 10 minus 2 x's. 10 minus 2 x's. So there's our volume. There's the equation for our volume. Okay, so to find out where the maximum is, we're going to have to take the first derivative of this thing and find out, since it looks like it's going to be what kind of a function. A linear times a linear raised to the third power is going to be a cubic function. So I'm imagining that this particular function that describes the volume is going to look something possibly like this. Now, I can't be sure about where the intercepts are right now, but we're going to try to find out where this maximum is. So if we take the derivative and find out where the derivative or the slope of the tangent line is equal to 0, we're going to find this maximum. We're going to maximize our volume. So far, so good?
Yes.
All right. Hold on now. Do we have a limit? Do we have a limit?
I don't think so.
So, what was it again?
Volume
Our
equals
volume equaled
parenthesis 10 minus 2x 10 minus 2x x.
x. Excellent. Okay, so let's do this first. Okay, so that looks like 100, right?
Mm-hmm.
Minus 20x's minus another 20x's is minus 40x's, and then finally negative 2x times negative 2x, positive 4x squared. That all still needs to be multiplied by
X.
x. So it looks like we're going to end up with, I'm going to rewrite this in descending order. So this guy times this guy, 4x to the third. This guy times this guy, negative 40x squared. And then finally the x times the 100, positive 100x. So that's v. Now, to find the derivative of v with respect to x, since it's a function of x, that would be what? 12, oops, I spit, 12x squared, right? We bring down the exponent, multiply by this constant up here, that gives us 12. Reduce this guy by 1, 12x squared. Plus, minus, what is it? 80x, right? The 2 comes up here, multiplies by the negative 40 to become negative 80. X to the 2 minus 1, x to the 1. Plus any linear, you take the derivative, you get just the constant. In this case, 100. So we got to figure out when this is 0. That'll give us the maximum. Okay, so, well, it's all divisible by 4, right?
Yes.
I can divide everything by 4. I need to set the derivative equal to 0. So dv over dx should equal 0. That's going to give us a slope that's 0. Equals, I'm going to divide everything by 4 here. Of course, if you divide 0 by 4, you get what?
0.
0. So that becomes 3x squared minus, help me out here, 20x plus 25.
Yep.
Okay, so when is this equal to 0? I'm not sure what factors of 25 and 3 I could mix up a little bit. To get 20, probably going to have to use the quadratic formula. So, value of x that's going to make this true, make this equal to 0, is going to be negative of negative 20 plus or minus a square root of negative 20 squared minus 4a c. Okay, all divided by 2 times a.
Question.
Go ahead.
Why negative 20 squared?
The equation for a quadratic, for the quadratic formula basically lets us know that if we have a quadratic equal to 0, the x squared coefficient is a, the x squared coefficient is a, which is 3 in this case. The x coefficient, which is negative 20, represents b, and 25 represents the constant, and I've just plugged in the values of a, b, and c into the quadratic formula.
Got it.
Should I remind you what the quadratic formula is?
No.
Okay.
I got it.
You got it?
Yeah.
All right, excellent. So the negative of negative 20 is what?
Positive 20.
20 plus or minus square root of, can you see that?
Yeah.
Negative 20 times negative 20, 400. Minus, oh, help me out here. 4 times 25 is $1, right? $1. And then times 3 is 300. Wow, I could have been able to factor this, I think. Is it 300? Yeah.
Yeah.
300 minus 300. Yeah, this was factorable. Sorry I didn't see it. 2 times 3, which is 6. Correct?
Mm-hmm.
I'm going to start back up here again. Where you going? Okay. All right, so I'm going to simplify this guy right here. So that looks like 100. So I have 20 plus or minus the square root of 100, which is 10, right? 400 minus 300, square root of 100, that's 10, over 6. So it looks like 20 minus 10 over 6 as well, which gives us what? That's what? 10 divided by 6, that's what? 5/3? Or 20 plus 10 over 6, which is 30 over 6, which gives us 5. So our two answers are 5/3 as well as 5. Now let's see if that actually gives us the same volume. Oh, wait a minute. I don't know which one of these is a maximum and which one of these is a minimum. Which one do you think is going to work here? Because one of our answers is 5 and one of our answers is 5/3. We don't know which one's a maximum or minimum. We just know that they're they're either maximums or minimums. Don't know which one. Now what we need to do is figure it out if they're concave up or concave down to be able to figure out if they're a maximum or minimum. If they're concave down, we got a maximum. If they're concave up, we got a minimum. So how do we do it? We find the second derivative, and then we plug in these values and see which one gives us a negative value. That means we're concave down. That means we have a maximum. If it's concave up, we should get a positive. There's where we should have a minimum. So let's see. Well, what was the first derivative? I think dv dx was, I forgot. 3.
Before.
Oh, it was what, equal to 20? No, 12 x squared minus 80 x.
Yep.
Plus 100.
Yep.
And then this guy became 3. This guy became
4.
This guy became 20.
20.
And this guy became
25.
25. Okay, so I think that was it. So one more derivative. So d squared of v, and this is the notation we use, dx squared, second derivative. That's equal to, what is that? 2 times 12 is 24x minus 80. Now let's see which one of these values gives us a positive or which one gives us a negative. We want the negative one. So I'm imagining it's going to be the 5/3. Right? Because if I multiply it by 5, I'm going to end up getting something bigger than 80. It'll be positive. I'll end up with a minimum. So I'm going to try the 5/3. So help me out here. 24 times 5/3, which become minus the 80, becomes, what is that, 8? So 5 times 8 is 40. Minus 80, we get negative 40. That's the value we want. We want to use this because that's going to give us a minimum. So let's see what it's going to give us. Back up here. So what was the initial value? Our initial volume happened to be, I'm going to write the original, which was x times 100 minus 2x times 100 minus 2x.
It wasn't 100, it was 10.
Thank you.
And what happened to the 100 on the bottom in that other equation?
Which one?
Right there, where it says 12x times...
This guy? We divided it by 4?
Yeah, so
and then we set it equal to 0?
So what happens to that on the bottom portion where you go 24x minus 80? Why doesn't that 100... Where does the 100 go, is basically...
This guy right here?
Yeah.
No, we took the derivative. That's a good question. What happened to this 100 when we took the next derivative, since it's a constant, it became 0. This linear term became a constant, and this squared term became a linear term.
Okay.
It's a great question. Yeah, this thing's gone after you take the derivative.
Okay.
All right, so let's see. 5/3 is what we were going to use, right?
Yes.
So let's see. 5/3 times 10 minus 2 times 5/3 times another 10 minus 2 times 5/3. Okay, so let's see here. This becomes 10/3. So here's 5/3. This becomes 10/3. This is 30/3, right? 30 over 3 is 10, correct?
Aren't you supposed to do the 2 times 5/3 first?
Yeah. I'm going to call this 10/3.
Okay.
So this, if I have to combine it with this, if I have 10 minus 10/3, it's the same as 30/3 minus 10/3. So this is 30/3 minus 10/3 in these parentheses. So that gives us 20/3. So 20 over 3 is the second factor. This guy's exactly the same. So another 20 over 3. So what does that give us? Looks like 400 times 5 is what? 2,000? 2,000
Thirds.
divided by, not 3.
Oh, 9.
Not 9. 3 times 3?
9.
Times 3?
Oh, 12.
What? 27. All right, 27. This is our max volume. Does that make sense?
Yes.